Greetings. This video is designed to show you how to use SPSS to conduct a correlational analysis. For assignment 4, the variables that we'll be using are gender, which is labeled 1 is female, 2 is male, a categorical variable, GPA, and then our final number of points on the final exam, and then the total number of points earned in the course. As with all our analysis, we start with looking at how our data meets the assumptions. And for correlational analysis like ANOVA and t-tests, the assumptions are normality of the data, heterogeneity of variances, or homogeneity of variances, I should say. Are the variances similar across groups? And we have another assumption for the correlation analysis, and that is linearity. In other words, is there a linear relationship between the variables that we're correlating in our analysis? Now, to do that, we can go to Analyze, Descriptives, and Explore. Now, we've done the Explore analysis several times before using our other assignments. We're going to put gender, GPA, final, and total in the dependent list. And for plots, I'm going to check none for box plots, histogram for descriptive, uncheck stem and leaf, and then check the normality plots. And then go continue and OK. Now again, you can see that we get the means and the standard deviations and all the other data for the variables that we're going to use in this analysis. Of course, the mean and the standard deviation for gender is meaningless because our gender data is categorical. But the means and the standard deviations for GPA, final, and total give us much more information about the central tendency and the variability of our data for each of those variables. And then for the tests of normality, we can see that if we look at GPA and we look at total, those data are significantly non-normal. If we look at final, we can see that because that value is above 0.05, we would consider that data normal or not significantly non-normal. Then we have our histograms for gender, GPA, final, and total. And for this analysis, what you're going to be focusing on is writing a research question and hypotheses for the relationship between GPA and final. So it'll be important that you include GPA and final in terms of the histograms for your report. Matter of fact, you should probably copy and paste all the histograms in your report and interpret them. So the next part of the analysis is to now look to see how these variables relate to one another in terms of their linear relationship. So in this case, we can go to Graphs and Legacy Dialogues and Scatterdot. So we're going to create a Scatterplot matrix of the variables that we're interested in. And so what we're going to do is move gender, GPA, final, and total into the matrix variables. And then we'll click on OK. Now, for these variables, what we're looking for is a linear pattern in the data. And we're not going to find it with gender because gender is a categorical data. It consists of ones and twos. But where we will see the linear relationship is with our interval level variables, so GPA and final. Although we have a somewhat of a scattered pattern, the preponderance of the data points are in a linear relationship. So in other words, low GPAs go with low final scores. High GPAs are related to high final scores. If we look at final and total, that's a very tight linear relationship. In other words, the higher your final score, the higher your total score. And then if we look at GPA in total, it's less related, still somewhat of a linear pattern, but not as remarkable as final and GPA and final and total. Now the next thing that you might want to do, well, you should do for your report, is create a scatter plot for just GPA and final, since you're going to be writing research question for the relationship between those variables. So let's go up to graphs, legacy dialogues, scatter dot, and then we're going to go to a simple scatter plot and we're going to define it. The two variables that we're going to work with again are GPA and final. So I'll put GPA on the x-axis and final, GPA on the y-axis and final on the x-axis. It really doesn't matter. You can do these interchangeably because the relationship will stay the same. And then we can click on OK. And so now you can see that we have one larger graph that just looks at the pattern or the relationship between GPA and final. And you can see that this is a very linear relationship. In other words, low GPAs are related to low final scores on the final exam. Higher GPAs are related to high final exam scores. So that's how we demonstrate that we meet the assumptions of linearity. We can even fit a line through that by double clicking in the middle, and I can click on this and then I can add my my line that fits the data. This is not something you have to do, but it's something you can do. Okay, so now for the main part of the analysis, we'll go up to Analyze, Correlate, and Bivariate. And what we're going to do is create what we call a correlation matrix. And so we're going to enter all the variables in this analysis into the variable section. And then we simply, well, one of the things we can do in options is we can get the means and the standard deviations. We did get that information from the Explore analysis. And then we can go OK. And so you can see that we have this correlation matrix. And so this gives us the combinations of all possible correlations between our variables. In this case, you can see the relationship between gender, final, and total. Now, this relationship, these are very small, so you're going to want to look in the Warner textbook and interpret the correlation in terms of its magnitude. And it's similar to an effect size. So you want to be able to interpret that correlations about 0.2 to 0.5 are, I should say 0 to about 0.5 are considered small. 5 to 0.8 are considered moderate to large, and then 0.8 and above are considered large correlations. But you might want to check the Warner textbook to see how she interprets those correlations. So you can see that the correlations between gender and GPA final and total are very small. In this case, the negative sign, all that refers to is that we have males and females, and that there's probably a difference in the mean GPA, the mean final, and the mean total scores for males and females. GPA and its relationship to final is 0.498, so it's basically a moderate correlation. GPA in total is also approaching moderate. Final and GPA is, oh, that's the same correlation here, of course. That's would be a moderate correlation. The largest correlation is between final and total, 0.833. And you can see the smallest correlation in the matrix is between gender and total, 0.120. Now keep in mind that GPA, final, and total would be considered Pearson correlations because they have interval level data. Although GPA might be considered ordinal data, and some might say that that would be more like a Spearman rank order correlation, or some other type of non-parametric correlation. Gender, because it's male versus female and is correlated with an interval level variable such as final and total, would be considered a point biserial correlation. So make sure that you write about those and interpret those correctly in your report. Now, for your final piece of advice for writing your report and answering your research question that you're going to pose about the relationship between GPA and final, you can see it right here. This is a relationship. The correlation is 0.498. And so you're going to want to interpret that and then answer your research question, and then decide whether you should accept or reject the null hypothesis. Thank you for listening. I hope this helps. Please let me know if you have questions. Thank you.